Hey, it's Coach Reese. Today I'm going to help you graph hyperbolas. Okay? We just got through dealing with ellipses. We graphed them, we wrote equations. You're going to see that we have some similarities and we have some differences. When we did an ellipse, we had shapes that could open and be stretched horizontally and stretched vertically. But the shape of a hyperbola can be this. If I have an x, let me erase this now. If I have an x in the top left numerator, my graph will open to the left and right, just like the x-axis opens up left and opens up right. If I have a y in the top left numerator, I have a graph that's going to open up and down, just like the y-axis runs up and down. So as we work the problem, as we complete the square, and we get our equation into this form, the variable is in the top left, tells you which shape that we're going to have on our graph, which way we're going to open. Okay? All right. So we're going to talk about some similarities, but right now we're going to talk about some differences. Okay? Obviously, you're going to see the difference. Look at the top, look at the numerator. I have it in red, but the top left-hand corner can be x or it can be y. The tops can change. When we were dealing with ellipses, the top never changed. It was the denominators that could move, okay? Or they would change because of the bigger value. But at the top left can be either x or it could be y, okay? This is a minus sign. Another difference is you have a subtraction sign instead of an addition sign, okay? One thing we also need to note, the denominators. A squared is always bottom left. When we had an ellipse, it's whatever number was bigger, that became a squared. Here, you have to focus, you have to remember, bottom left denominator is always a squared. Bottom right denominator is always b squared. Okay? So, what is new? The positive squared parentheses is always the top left. Got it. There's a subtraction sign. Got it. Here's another thing. We're going to need to find the c value to help us find the foci. So we have a different equation now. The equation to find the c value is a squared plus b squared equals c squared. The ellipse had a minus sign. Also, you're going to have something called a transverse axis. It's a segment that connects the vertices. It's going to go from one vertex to the other. Its distance will be 2a. You're going to have a conjugate axis. It's a segment that's perpendicular to the transverse and it also passes through the center, and its length will be 2b. Also, they're going to have what's called the slopes of the asymptotes, and these are lines that are passed through the center and the corners of a rectangle or a box that we draw that is formed using the a and the b values. So all these things are great, but they don't mean a whole lot until we do them, okay? So I think you're going to learn a lot more about these things as we work a couple of problems. So let's get right into it. All right, excuse me. The first problem we're going to do looks like this. So when we get a problem and we have to complete the square, we need you to start with the positive squared term. I have an x squared and I have a y squared. But the y squared is positive and we need to start with that one first. Always start when you complete the square with the positive squared term first. So we're going to say y squared plus 6y plus blank. We're going to complete the square. We're going to say negative x squared minus 4x plus blank. We need to move the 1 to the other side, so we're going to subtract it. We're going to get negative 1 plus blank plus blank. Okay? All right, so here we have a negative in front. This is going to mess with us. Remember how we have to factor things away and bounce? This is what's going to happen here. I don't have anything in front of my y squared, so we're just going to hold off on the y's. So watch what I want you to do. I I want you to keep coming. I want you to say y squared plus 6y plus blank, but I want you to factor away the negative. And that's going to give me x squared plus 4x plus blank equals -1 plus blank plus blank. Okay? I need you to pull away that negative. Okay? And since we factored, we're going to have to bounce. All right, so half of 6 is 3. We're going to square it. 3 times 3 is 9, so 9 goes in the first blank. 9 goes in the first blank. Bring your minus. Half of 4. Half of 4 is 2. I need you to square the 2. But you're going to have to bounce this negative sign. A negative times that 4 is going to give me a -4. We're going to do the math. -1 plus 9 is 8. 8 minus 4 equals 4. Okay? But just like an ellipse, I need this to be equal to 1. So to get there, we're going to divide every term by 4. And that will leave us with y plus 3 squared over 4 minus x plus 2 squared over 4 equals 1. Don't panic. It's okay if they are the same number in the denominator. Okay? Real quick though, I need you to go back in our notes. We're going to look. No matter what, the bottom left denominator will always be a squared. The bottom right will always be b squared. So we're working this problem. This is going to be a squared. This is going to be b squared. And if that's a squared, then a is going to equal 2, and b is also going to equal 2. Got it? We need to find our center. Take a deep breath. Don't get in a hurry. Your center is always going to be h, comma, k. This is going to be x minus h, y minus k. But look where this is located. You have to be careful. This, when you take the opposite, should come here. When you take the opposite, this should be here. Make sure you're paying attention to where the x and the y are located so you can write your center correctly. All right, so you have a -2 comma -3. We're going to come to our graph. We're going to say -2, -3. But while we're looking at this, I want you to notice this y, the y is in the top left-hand spot. That y is in the top left-hand numerator, and because that's a y, my graph will open up and down. Just remember this. If this is a y, we're going to open up and down. If it's an x, we're going to open up left and right. Okay? So now we're going to find our a value because it's going to take us to our vertices. Just like an ellipse, the a value will take you to your vertices. Okay? We know we're going to open up and down, so we're going to count up 2. My a value is 2. So we're going to go 1, 2, and put a little curve to start. We're going to go down 2. 1, 2, we're going to put a little curve to start. We need the location of those vertices. And they're going to be located, my vertices are located at -2, -1, -2, -5. Okay? Now, what you need to understand, you just found this. From this vertex to that vertex. From vertex to vertex is what we call the transverse axis. And they're going to ask you for the length. So how far is it from vertex to vertex? We're going to say that the length of the transverse axis is 2a. So in this case, 2 times 2 is going to equal 4. There is your length of your transverse axis. You're also going to have another thing called the length of the conjugate axis. And it's going to be perpendicular, and we're going to go through the center, and we're going to say 1, 2. We're going to count 1, 2, and we're going to put a little line. And we're going to go the other way, 1, 2, and we're going to put a little line like that. Because our B value is 2, the B value is going to help you find the location of your conjugate axis. So from the edge of the conjugate to the other edge, that's going to be 2b. The length of the conjugate is 2b, which also equals 4. So now this allows us to sketch what we call a little box. A lot of times it's going to be a rectangle. This time it's going to be a square. But we're going to sketch this. And so from the edge, we're going to use the conjugate axis. We're going to go through the vertex using the transverse length. And we're going to sketch a little box right there. Now, from that box, we're going to go through this corner, and through the center, and we're going to draw what we call an asymptote. So we're going to try to draw a straight line. I'll do the best I can. And we're going to go through the other corner and the center and draw another asymptote. Okay, that's all I got. But those are your asymptotes. But we're going to ask you for the slopes of those asymptotes. And slope is always rise over run. So we're going to have a positive slope. We're going to have a negative slope. So I'm going to ask you to write y equals a positive, negative. We're going to go up 2 boxes. We're going to go to the right 2 boxes. That's going to reduce to 1. You could tell me that y equals a positive, negative 1x, or you can just say the 1 is optional, positive, negative x. But we're worried about the slope of the asymptotes. The last thing we need to find is our foci. But we're going to kind of finish up our graph. So look what we're going to do. To do our graph, I'm going to ask you to go to your vertex, approach the asymptote, but don't touch it. We're going to approach the asymptote and not touch it. You don't have to be exact when you draw your hyperbola, but you're going to start at the vertex and curve and approach the asymptotes. Now, your foci or the focus will be inside the curve. Just like it was with the parabola, it's going to be inside that curved area. And how do we get there? We need the C value. The C value will take us to the location of a foci. Okay? We were given an equation in our notes. Our notes say a squared plus b squared equals c squared. If you remember, a squared was 4, b squared was 4. So we're going to say 4 plus 4 equals c squared. 8 equals c squared. I don't need c squared, I need c. I need the location of c. We're going to take the square root. We're going to take the square root, and we're going to find out that c equals 2 square roots of 2. Now, we know that the foci are going to be located up and down, vertically. So we need to make an adjustment to the y value of our center. So on our center, we were at -2, -3. So we're going to say -2, -3, but we need to make an adjustment to the y value. We're going to add and we're going to subtract the amount of 2 square roots of 2. this will be the location of our foci. Got it? Now, if we wanted to actually graph this, look at this. C squared equals the square root of 8. Okay? One way to tell you what C is equal to, the square root of 9 is 3. We would be 8 is almost to the square root of 9, so we're going to be just a little bit less than 3. So you can go to your graph, and you're going to say, I'm going to count from the center, and I'm going to go 1, 2, just a little bit short of 3. 1, 2, just a little bit short of 3, and that's how the easiest way to graph your foci. Okay? This is one example. You might be confused a little bit. Let's try another one. Okay? All right, so what I told you to do, if you remember, I said, look at your squared terms. We want to always start with the positive. In this case, 9x squared is the positive. We're going to start with that one first. We're going to say 9x squared plus 18x plus blank. We're going to complete the square. Minus 4y squared. I don't have anything to pair with the y squared. So that means this is going to probably get us a 0. We only have to complete the square once. We're going to move the 27, so we're going to say equals 27 plus blank. We're going to factor away the 9. We're going to get x squared plus 2x plus blank minus 4y equals 27 plus blank. If you factor, you're going to bounce. Okay? So bring the 9 down. We're going to ask you to take half of 2. Half of 2 is 1. We're going to square that and put it in the blank. And then we're going to bounce the 9. 9 times 1 is 9. Minus 4y squared, I forgot my square there, y squared equals 27 plus 9 is 36. Almost through. We're going to divide everybody times 36. When we reduce the 9 over 36, this is going to leave us with x plus 1 squared over 4. The 9 over 36 reduces to a 4. Minus, we're going to reduce the 4 and the 36. That's going to leave me with y squared over 9. And that's going to equal 1. Now remember, bottom left, we said that the bottom left, no matter what, is a squared. Bottom right is b squared. So in this case, a equals 2, b equals 3. Now, if you wanted to, now that you know that a is 2 and b is 3, we know that the length of the transverse axis is 2a. So 2 times a is 4. We know the length of the conjugate axis is 2b. So 2 times 3 is 6. You can take care of those real quick. The center, be careful how you start. Here's your x, so that can give you your h. So in this case, my center is going to be -1, comma, I don't have a parenthesis, so that's going to be 0. There is the center of my hyperbola. I'm at -1, 0. Before we go too far, look what variable's in the top left-hand position. It's an x. So since there's an x there, that tells me that my graph will open up left and right, because that's the way the x-axis runs. Okay? Remember that. We're going to find our vertices. To find our vertices, we're going to use the a value. A equals 2, so we're going to have to go to the left 2 and make a curve for the first vertex. Go to the right 2 and make a curve for the next vertex. We need the location of those vertices. So we're going to be located at -3, 0, and we're going to be located at 1, 0. Now we have the length of the transverse axis, the length of the conjugate. So the conjugate, we're going to use the B value. So we're going to go up here and we're going to say B is 1, 2, 3, put a little line. 1, 2, 3, little line. These help us draw our rectangle or our box. So we're going to draw our little box. That box is going to help us draw our asymptotes. We're going to go through the corners. So we're going to go through this corner, through the center, and this corner. We're going to do the best we can. And from this corner, through the center, through this corner. Those are our asymptotes. So we're going to write that equation. We're going to want the slopes. And remember, it's rise over run. So we're going to go up 1, 2, 3 over 2. So we're going to say that y equals a positive negative up 3 to the right 2. I'd like you to put a little x there, but those are the slopes of your asymptotes. Okay? We're going to finish out our graph. We're going to draw our hyperbola. Remember, we said which way? It's going to open up left and right. Okay? So we're going to finish out. We're going to go from our vertex. We're going to go along the asymptote. We're going to along the asymptote. Doesn't have to be too pretty. But inside this curve is the foci. How do we get there? We need our C value. Our C value will get us to our foci. So to do this, our equation says A squared plus B squared equals C squared. Look at your A squared and your B squared. A was 4, A squared was 4, B squared was 9. So you're going to tell me that 4 plus 9 equals C squared. You're going to tell me that 13 equals C squared. And you're going to take the square root. And you're going to tell me the square root of 13 equals C. All right? But we're going left and right to plot our foci. So since we're going left and right, we have to make an adjustment to the x value of our center. So you're going to say -1 plus or minus the square root of 13, comma 0. There's the location of your foci. Okay? Now if you want to graph it, you got to think about 13, the square root of 13. It's a little bit more than 9. It's a little bit less than 16. The square root of 9 is 3. The square root of 16 is 4. So we're somewhere about in the middle. Okay? So you're in the middle between 3 and 4. So come to here and come to your center and count. 1, 2, 3, 4 in the middle of 3 and 4. 1, 2, 3, 4 in the middle of 3 and 4, and you have graphed. I know it's different. It could be a little bit tricky. Give it a shot. Just try, and if you get stuck, let us know. Let us help you. Good luck.